Okay? So again, in the plane C equals 6, which is on top here, which is maybe the first plane I ask you to think about, because we can do, you got 6 sides of this thing, right? Okay, so we could intersect it with any side. And it's kind of interesting to do that, to get the whole picture of this surface and the way it intersects this cube gives you a pretty good picture of what the surface looks like. Okay? But just confining ourselves to, for the present, to plane C equals 6. If C is 6, C squared is 36, so C squared over 4x is 9 over x. And you have the point 33, you have the point 91 out here, you'd have the point 19 up here, okay? So we can see where 33 would be. Well, right here is 2 in the xy plane, right? So 33 is just about here, okay? So there's a point 33, and it projects up to a point 33 up here, okay? And then your hyperbola looks something maybe like this, where it intersects.
It hits at 2, 9/2, 9/2, 2.
Yeah, and that's the next thing I was going to do. Where's this and where's this, right? Which is 4.5, which means I didn't draw it too badly. Okay, 4.5 is a little closer to 6 than it is to 2. So here we have the point. It's 2 9/2. 9/2, 2 is the other one. Here's a point. 2 9/2, that's 4.5, right? And here's the point 9/2, 2. Okay? Well, it's kind of shaped like this as you come away from the origin, okay? Which means that, well, along this side of the cube, over here, what's the intersection going to look like? Well, maybe it's a straight line, maybe it's something else, you can work it out, but it's got some intersection, and that intersection kind of goes back toward the origin. So I'm going to redraw this, but I'm going to turn the cube around like this, so that we're kind of labeling or drawing things on faces that we can see. Okay, because right now these two faces are hidden, and that's where you need to see what there is to see. Okay? So if we draw the cube again, I'm not labeling anything. Okay? Now the intersection point is here and goes kind of like this. Okay? So we've kind of rotated the whole coordinate system around so that the x-axis is going back in this direction, the y-axis is going in this direction. And of course then here's your z-axis, which I'll draw very lightly so it doesn't hide anything. Okay? And here again is 2, and here's 2, and so forth, right? Just be oriented. So we can see that if we turn everything so the x-axis goes 180 degrees, it's going to look like this, and now we can see it. Make sense? Okay. So there's some sort of a curve here, and probably going to look something like this. Uh-oh, wait a minute. My y is still...
The top one isn't drawn quite right. It's supposed to be...
I have this right? Yeah.
It's supposed to hit the line going into...
Yeah, you're right. You're right. Okay. Glad somebody knows what they're doing here. Okay, so let's make it... I want it to be somewhat clear, so let's see if I can clean that off just a little bit. little careless there. Okay. And then it's gonna come down like this. Okay? Now you've got then what we might think of as a green region between here and here. Okay, it's like we're chopping off this corner, right? And what we want to do is we want to figure out what the volume of that chopped off part is, because it's going to be totally relevant to our ultimate question about the quadratic. And this is where we have to develop a little bit of technique for multiple integration. Okay? But it's not really too difficult intuitively. There's things that need to be proved, but let's just work through this just a little bit, okay? So, well, I'm going to go off camera and draw something, but